Kicking us off, we're going to start by introducing the Liferay Message Bus. The Liferay Message Bus is a service-level API used for exchanging messages inside of Liferay. It's similar to JMS, but has a smaller feature set. It has support for synchronous and asynchronous messaging. Transactional and reliable delivery are not supported, and it has cluster messaging support with Liferay Cluster Link. Some Message Bus use cases include things like any time-taking operation that should not block request processing. Those are things like sending bulk emails, running scheduled tasks, file processing, cluster communication, auditing, and sending payload to an integrated system. What does Liferay use the LMB for? Well, Liferay uses the LMB for auditing, search engine integration, running asynchronous background processes, running scheduler tasks, running cluster operations like cache replication, document library processing, sending subscription emails, monitoring, and running Liferay hot deploy. The LMB works with a few components. There's the destination. This provides listening on the addresses or endpoints to which the listeners are registered to receive messages from. We have the senders, which invoke the message bus to send messages to destinations. And we have the listeners, which receive messages sent to the registered destinations. And here we can see a picture of that. We can see the three components here. So we have our senders sending messages to the message bus, which is the destinations, and we have listeners listening on those destinations. Destinations are named endpoints for sending messages to and receiving messages from. They provide a loose coupling between a sender and a listener, and these are all OSGI services. We have three different destination types. We have the parallel destination type, which receives messages and queues them. And this means that there's one worker thread per message listener. We have the serial destination type. Received messages are also queued, and we have one worker thread per message. And we have the synchronous destination type, which has no queue, and the thread sending the message here delivers the message to all message listeners. Here we have a picture of the asynchronous and parallel destinations. So what's happening here is we have a sender who sends a message to the message bus, but doesn't get held up. It actually continues processing here. The message bus continues to send the message to the parallel destinations, where all those processes are processed in parallel. Alternatively, we have the synchronous and serial destination, where the sender sends a message to the message bus, but that message actually blocks the processing for the rest of the sender's request. The next portion of the Liferay Message Bus is senders. Messages can be sent either directly to the message bus, asynchronously using a single destination message sender, or synchronously using a synchronous message sender. Here we have an example of a direct sending. What we're going to do here is we're going to send message on the message bus as noted in the highlighted section. And the parameters that we're going to pass are the destination name and the actual message. Make sure that we're referencing message bus, as you can see in the second highlighted portion below. After that, we have asynchronous sending, which means that after a message is sent in a different thread, the sender is free to continue processing. And we do this by setting a response destination. And by setting a response destination, a callback can be provided, but that needs a listener. We have an example of asynchronous sending here. What we're doing is setting the response destination name for the message. In this case, we'll be setting it to training response destination. And then we're going to create a single destination message sender, which we're going to call message sender. Then we're going to do message sender factory dot create single destination message sender, and we'll provide it that same training destination name. Thirdly, we have synchronous sending, which blocks the thread until receiving a response or the response times out. There's two different types of operation modes. It's the default mode, which delivers the message in a separate thread with timeout, and the direct mode, which delivers the message in the same thread of execution and blocks it until it receives a response. Use this if sequence order has to be guaranteed. Here we're going to see a synchronous sending example. We're going to create a single destination synchronous message sender. We're going to call that message sender. And then we're going to use the message sender factory to create a single destination synchronous message sender. We'll go ahead and pass that training destination name and the direct mode as parameters. The third portion that we have is listeners. So we have three different kinds of listener registration methods. The first one is automatic registration as a component. This allows us to publish the listener to the OSGI registry as a declarative services component that specifies a destination. The message bus automatically wires the listener to that destination. The second way is registering via message bus. It allows us to obtain a reference to the message bus and use it directly to register the listener to a destination. And the third one is registering directly to a destination. So we'll obtain a reference to a destination and use it directly to register the listener with that destination. Quick example here. Inside of our component, we'll set a property called destination name, and we'll use that training destination name. And we'll specify the service as a message listener.class. For listeners in a cluster, we have a cluster bridge message listener component, which has to be registered at the destination. And here we have a cluster listener example. Similarly, we're going to specify the service as message bus cluster listener.class. And then inside the activate method, we're going to specify that cluster bridge message listener equals new cluster bridge message listener. And then we're going to register the cluster bridge message listener as a destination. Next step is the message bus and service builder. So service builder leverages message bus with two annotations, the async annotation and the clusterable annotation. So for async, message bus calls to a public method annotated with async will be asynchronous. This allows you to implement fire and forget capabilities to the services and is useful for features like notifications. For clusterable, any service method annotated with clusterable will be invoked across the cluster. We have two attributes here, onMaster, which, if set to true, will only execute the request if the current portal JVM is holding the cluster-wide master token, and acceptor, which specifies a custom cluster invoke acceptor to determine whether a given portal JVM should accept and execute the request. Message bus statistics. So message bus destinations are actually available as mbeans. And here what we're seeing is JConsole, and we can see that inside of JConsole, under messaging destination, we have these attributes, and under the attributes, we have the different message bus destinations. So for message bus statistics, we can see that message bus destinations are actually available as mbeans. So inside of JConsole, we can see here that we have just a list of messaging destinations. The first one is going to be Liferay Message Bus. It's a service level API for exchanging messages inside Liferay. The message bus has three main components, which are the destinations, the senders, and the listeners. And the Liferay service builder can leverage the message bus with two annotations, async and clusterable.